Hey everyone, this is part 1 in our series on the practice final for AP Statistics. How's everyone doing? Pretty good. That's awesome. Here we're going to be looking at questions 1 through 10, and we're going to get right into it now. So question 1 says that an office supply company gives a description of bookshelves that includes the following variables and which is categorical. So the key here is to think about how one would respond or typically respond to one of these variables. So for the first one, when it asks you, what is the width of the bookshelf in inches? So if someone asks me what is the width of the bookshelf in inches, a typical response would be 40 inches, which is a quantitative response. It's an answer in numbers. Second one here is the width of the bookshelf in feet. Just like before, the typical response would be something like 3.2 feet, which is quantitative. Now the next one says the color of the bookshelf. So a typical response here would be chestnut. It's not a numerical response, so we would have to call this a categorical response. We're going to go with the rest of these just to see what we would come up with, just as good practice. So the next one here is the height of the bookshelf in inches. Typical response here would be like 68 inches. That's quantitative also. And the last one here would be the weight of a bookshelf. Typical response there would be like 12 pounds, and that's another quantitative response. So the answer here that is categorical, note that's what we're asking for. That answer is letter C, the color of the bookshelf. Moving on to question 2. The table shows the results of the New Hampshire Republican primary on January 10, 2012. Here we've got the candidates. Mitt Romney got 39% of the votes, Ron Paul with 23% of the votes, etc. And the question here is, which of the following lists of graphs are all appropriate ways of presenting this data? So the thing that I want to highlight for you is that these are all categorical data. Mitt Romney is, that's not a numerical response. We're counting how many people or what percentage of people voted for Mitt Romney in that Republican primary. So our responses here would be categorical, which means that any of these that have to do with a quantitative response are going to be wrong. So quantitative graphs are box plots, histograms, stem plots, anything like that that requires a numerical, a number that makes sense, that would be disqualified here. So let's see, bar graph and pie chart, both of those are appropriate for categorical data. So both of those would be correct here. So letter C, bar graph and pie chart. And that brings us to question 3 here. Below is a two-way table summarizing the number of cylinders in selected car models manufactured in 6 different countries. So the different countries here are France, Germany, Italy, Japan, Sweden, and the USA. The number of cylinders would be 4, 5, 6, and 8. I've never heard of a 5-cylinder car, so that's kind of crazy, just coming at it from that angle. But the question is asking for a marginal distribution. So what is a marginal distribution? Well, a marginal distribution would be either by percentage or by count how many of each category there are. So when I take a look at this first one, the percentage of all 4-cylinder cars manufactured in Germany, you would answer that with a single number. So that can't be the correct answer. So since the percentage of all four-cylinder cars manufactured in Germany would be answered with a single number and not a distribution, not a bunch of different numbers for each category, that would definitely not be a marginal distribution. The same is true about letter B, the number of four-cylinder cars manufactured in Germany. That's just a single number, so that's not correct. The percentage of cars manufactured in each country, well, that's promising. The fact that we're saying in each country means that we're going to have to answer that with 6 different values, 6 different percentages. So I'm going to leave that in there for now. Letter D says the percentage of cars manufactured in Germany for each number of cylinders. And while that does sound pretty good, the fact that it's only Germany makes this not a marginal distribution. So again, we'll have to disqualify letter E or letter D. And we're actually going to disqualify letter E as well, because it says the number of cylinders, 4, 5, 6, and 8. Well, you know, that feels really good because those are numbers, it's a range of numbers. However, those are the names of the categories. Those numbers don't actually have any meaning as far as they're not counting anything, any number of countries. So that's actually not correct. So based on what I'm seeing, the correct answer here should be letter C, the percentage of cars manufactured in each country, or the percentage of all cars manufactured in each country. And by the way, that response would correspond with these values right here on the right margin. So that would be the marginal distribution. Question 4. The population of the United States is aging, though less rapidly than in other developed countries. Below is a stem plot of the percentage of residents that are 65 or older in each of the 50 states according to the 2010 census. There are 3 outliers. Alaska has the lowest percentage of older residents. So the lowest percentage here would be this one, 77%, or I'm sorry, 7.7%. And Utah had the second lowest. So Utah here would be 9.0, second lowest. And of course, Florida is the highest. So Florida would be at 17.3%. So what is the percentage for Utah? We already discussed that. That's 9.0%. So letter B would be correct here, 9%. Number 5 says there are 3 children in a room, ages 3, 4, and 5, and then another 4-year-old child will enter the room. So what's going to happen? So here is the dot plot of before that 4-year-old child enters the room. Let's move this down just a little bit. And notice it's a uniform distribution, of course, and nothing too crazy. The mean and the median are the exact same number because it is symmetric. So we're looking at a mean and median value of 4. So what happens is another 4-year-old child enters the room, and I'm going to put that dot in now. So we can see from the dot plot that the mean and the median are still 4, which automatically means that D and E are wrong because those indicate that the mean is going to increase or decrease. And that central value stayed the same. This typical center value is still going to be 4. So the mean age is going to stay the same, but what's going to happen is that we have weighted the center of this distribution more. So we went from a uniform distribution to a single peak symmetric looking distribution. And since a single peak distribution that's symmetric has a smaller variance than a uniform distribution, what's going to happen is the variance, or in any any measure of variation is going to decrease. You can think of this as this distribution is getting centrally weighted, so everything just kind of moves toward the center. So the correct answer here should be B. The variance is going to decrease. All right, that brings us to number 6. A sample of 99 distances has a mean of 24 feet and a median of 24.5. Unfortunately, it's just been discovered that the maximum value of the distribution was erroneously recorded as 40 when it should have been, or it actually had, a value of 50. So if we make that correction, what's going to happen? Well, we can think about that if we just take a look at the, any dot plot about this. If we decided to increase the maximum value, well, the score in the center is going to actually stay the same because it's not moving relative to the highest value. Okay. So for example, if I take a look here at the previous dot plot, if for example, this dot over here was not actually at 5 and it was actually at 6, is that going to change the center value? No, it's not. The center value is still going to be 4. The maximum doesn't really affect the center value at all. So with question 6, anything that indicates that the median is going to change is going to be wrong. So if I'm taking a look at this, letter D, the median is increased. That's wrong. Letter A, the median is increased. That's going to be wrong as well. So the median is going to increase. What's going to happen to the mean, however, the median is going to stay the same. But what's going to happen to the mean is going to increase. So the mean is affected by the values. And the fact that the mean is affected by those extreme values, that has a special name. It means it's non-resistant. And you might remember that the median is actually resistant. Or the median is a resistant measure of center. So let's see, the mean is definitely not going to stay the same. The mean is going to increase because we have an increased maximum. So letter C looks pretty good now. The median remains the same. The mean is increased. And we should take a look at E. Letter E says we cannot determine how the mean and median are affected without further calculations, but the variance is increased. Now that sounds pretty good because the variance is going to increase. We are going to have more variation with this new data. However, we can calculate what happens to the mean, we can calculate what happened to the median for sure. So that first part here is not quite correct because we can tell you what's going to happen to the median without any further calculations. The correct answer here should be this one right here. The median is going to stay the same, but the mean is going to increase. Number 7. We've got 100 people working at Lag Time Internet Services. That's a cute name. Suppose after a particularly successful year, the president of the company decided to double his own salary and not change anyone else's. So this is sounding a lot like the previous one. We're going to change the maximum salary because assuming the president makes more than anyone else, which of the following changes is going to be true about measures of center and spread? So the mean is definitely going to increase because we are now adding more money to the total. We're increasing the maximum. So that is going to change the mean. The mean is not resistant. Standard deviation is going to increase. That's true. However, what about the median? The median is going to stay the same because we're only changing the maximum value. And the median is resistant. The IQR is also going to stay the same for pretty much the same reasons that the median is going to stay the same. So if you increase the maximum, the Q3 is not going to change because it's still going to, the salaries in this case are still going to line up exactly the same way if we order them from 0 to 100, or if we put them in order numerically. Q1 and Q3 are going to stay the same, only the maximum is going to increase. So it sounds to me as though letter A is very attractively worded. The mean and the standard deviation will both increase, but the median and IQR are going to stay the same. So that sounds pretty good. Let's go through the rest of these and see if we can find error. The mean and the IQR will increase. Okay, so this is again telling me that the IQR is going to increase, and that's not going to happen. That IQR is not going to change because Q1 and Q3 do not change with an increased maximum. Letter C, the mean, standard deviation, and IQR will all increase. So this one's wrong because, again, we're talking about that IQR increasing, and that's not going to happen. Okay, letter C says the mean will increase, but the median, standard deviation, and IQR will stay the same. Incorrect here. The standard deviation is actually going to increase because we are increasing the amount of variation. Increasing the maximum will also increase the amount of variation because a typical distance from the mean is going to increase. And looking at letter E, we have the interquartile range will all increase. So of course the interquartile range does not increase. And that leaves us with letter A as the correct response for number 7. Let's take a look at number 8, the 5-number summary for scores on a stats exam are 11, 35, 61, 70, and 79. In all, 380 students took the test. How many students had a score between 35 and 61? Well, let's see, 35 and 61. 35 is right here at the left of the box. And then 61 is right here, the median score. So between Q1 and the median is about 25% of all scores. So since we have 380 scores, 380 students, the correct answer here should be 95. Now notice that there are no other responses that are even close to 95, so it's pretty unambiguous that 95 will be the correct answer here. If yours a 95 and a 96, maybe you might be feeling like you're going to get tricked because sometimes when the numbers don't work out correctly, things get kind of crazy. But none of that's going to happen here, so 95 looks like the correct answer. Okay, so let's move on to letter number 9. The 35th percentile of a population is a number x such that, so 35% means that 35% of all the data is less than or equal to x, and also 65% are greater than or equal to x. So by definition of percentile, at least 35% of the population scores are less than or equal to x, and at least 65% of population scores are greater than x. So if both of those statements are true, then you have the correct value of the percentile. Now, these are all a little bit weird. 35% are above x. Now, that can't be correct because 35% need to be below x. 65% of population scores are above x, and that really should be 65 or more percent. 65 or more, or at least 65% are above x. But 65, that sounds decent. Not exactly correct. Let's take a look at letter C. 35% of population scores are equal to x, and no, that's not correct. 35% are less than equal to. X is 35% of the population median. And that's a really weird number because the median is just a value. 35% of that value is X, is the percentile. That's not quite correct. That's a weird one. And for pretty much the exact same reason, letter E is wrong. 35% of the population mean is not necessarily going to be the 35th percentile. So it looks like the only answer here which is viable would be this letter B, even though I have some issues with this. 65% of the population scores are above X. It really should be 65% or more are above X. So let's take a look at, I'm not super happy with number 9, but that's the way it goes sometimes. It's the best answer of the ones that we got. Now, if we had a none of the above, then it'd be a real choice for you to make, but that's not going to be the issue here. So let's finish up this video with number 10. Jessica is studying starfish populations and collected starfish of the species Pisaster. She was interested in the distribution of sizes of starfish on a certain shoreline. One measurement is arm length, and below is a cumulative relative frequency distribution for the arm length in centimeters of 102 Pisaster individuals. So, the Pisaster arm length of a particular starfish is 18.2 centimeters, and we're asking if that is unusually large. Unusually large would usually mean at the 95th percentile, at or above the 95th percentile, or at or below the 5th percentile. And the percentile is the same thing as the cumulative relative frequency. So one thing we could do is we can take a look at where exactly is 18.2. So I'm going to go ahead and put my cursor here right around 18.2. I think that's kind of close. We'll just go up to 18.2 and then over to get its percentile rank. So it looks as though the percentile rank of 18.2 is, it looks like an 85th percentile. So the first thing that we can do to eliminate answer choices is to take a look at the percentile ranks that they give. So this letter A, it says the 10th percentile. It's definitely not the 10th percentile. Letter B says the 18.20th percentile. No, we estimated right around the 85th percentile. Number C, the starfish is approximately at the 90th percentile, and 90 percentile, that's really close to what we got. So let's leave this guy in there for now. Letter D, the starfish is approximately at the 10th percentile. No, it's not at the 10th percentile. And letter E, the starfish is approximately at the 18.2nd percentile. 18.2th percentile? And no, that's not correct. And just by eliminating based on the percentiles, the only answer here which is viable is this letter C. Even though we estimated the percentile to be 85, the rest of these are really far away from 85th percentile. So that has to be correct. So that does it here for the first video, numbers 1 through 10 of your AP Statistics final exam practice. Good luck, and we'll see you on the next video.